We've already seen the definition for conditional probability. It's given by this fraction here. If we take this expression and simplify it, we end up with a very useful principle. Multiply both sides by the probability of f, and we get this principle here, which says the probability of E and f happening is the probability of f times the probability of E given that f already happened. This allows us to calculate multi-step problems fairly simply. For example, we're going to take a look at an interesting deck of cards. There are going to be 11 cards in the deck. 3 of the cards are going to be red, 1 key, 1 sun, and 1 door. There will be 3 brown cards with the same symbols, 2 additional cards called the Nightmare and the Dream, and then 3 green cards with those same symbols. With these 11 cards, we're going to perform an experiment. So we're going to draw 2 of the 11 cards, and we'd like to know what's the probability that the first card is going to be red and the second card is going to be green. We're going to do this using this multiplication principle. We have 2 different things happening. We have a red card and we have a green card. And what the multiplication principle says is that the probability that both of them happen is the probability of the one times the probability of the other, given that the first one happened. So F is going to be our first card and E is going to be our second card, and we want to know what the probability of the first card being red is. 3 out of the 11 cards are red, so the probability is 3 out of 11. We also need the probability that we draw a green card given that the first card was red. Now, we've taken one of the red cards out of the deck, so there are 10 cards left. Out of those, 3 of them are green, so the probability of green given red is 3 out of 10. Putting these together, the multiplication principle says the probability that we have a red and then a green card is just the product, or 3/11 times 3/10. What we did symbolically was F was the first card is red and E is the second card is green. You should go back and make sure this makes sense. There are going to be some situations where the multiplication principle becomes even simpler. Let's say I'm going to roll 2 dice. I rolled the first die and I get a 5. Given that the 5 was rolled, what's the probability the second die was an even number? Well, it shouldn't make a difference, right? The given part doesn't matter. 2 events are called independent if assuming one does not change the probability of the other. Just like with the dice rolls, the 5 didn't make a difference for the second roll. The symbolic definition is that the probability of E given F is the probability of E, and the probability of F given E is the probability of F. This makes the multiplication principle much simpler, because in an independent event case, the probability of E given F is just the probability of E. So when the events are independent, the multiplication principle becomes really easy to use. As an example, let's take a look at this. What is the probability that a coin comes up heads 3 flips in a row? Since coin flips are independent of each other, we can use this new multiplication principle. The probability that we get 3 heads is going to be the probability we get a head on the first, multiplied by the probability we get a head on the second, multiplied by the probability we get a head on the third. We know each of those probabilities, each of them is a half. So my probability of 3 heads is just going to be the product of a half 3 times, or 1/8. Some classic examples of independent events are rolling dice and flipping coins. Some classic examples of dependent events, things that don't use this new multiplication principle, are drawing cards and pulling stones from an urn.